Hello everyone, good morning. Myself and Praveen Kumar Reddy, working as assistant professor at electrical department in R&D Engineering College, Chennai. So today, I just want to give you some brief introduction to embedded systems and their classification. So what is embedded system? Is okay. So if we see on the screen, there are a lot of electronic systems which we use in our everyday life. All these electronic systems are called as embedded systems. In a general definition, we can say an embedded system is a combination of hardware and software. That means that, for example, you consider a cell phone which you are using. A cell phone is an embedded system where it is having some hardware inside, like a PCB, printed circuit board, or a processor, and some other components on the PCB, like memory, RAM, ROM, some etc. As well as it also contains some software which is called as Android OS, which controls all the hardware. So you have a software that is Android, and you have a hardware that is processors and other things. So your cell phone is a combination of both hardware and software. So you can simply call your cell phone as an embedded system, software included inside a hardware, okay, inserted in a hardware. Like that, you can take any other examples in your daily life which you come through, like a washing machine in your home. It is also an embedded system. It is also having some software and hardware inside. Your car is no more a simple electromechanical system, mechanical system. It is nowadays advanced cars is completely electronically controlled, right? So there are various examples you can think about. All the electronic systems are embedded systems nowadays. So here I just want to give you some uh, information about why the classification is given like this. So types of embedded systems, they are basically classified into two things based on the performance and functional requirements and based on the performance of the microcomputer. So if you see the first one, based on the performance and functional requirements, it is classified as four types: real-time embedded system, standalone embedded system, networked embedded system, and mobile embedded system. What is this classification? First of all, let's go to the first one, real-time embedded system. What is real-time? To understand this, let me show you one thing. This is a car where this nowadays advanced cars are having a lot of infotainment systems, like you are able to see, play the music from your touch screen or dashboard. You will be able to see, navigate through Google Maps. You have a lot of electronics and involved in this. There is information and entertainment in your car. Like you can play the music, you can get the information about the Google Maps and all those things. As well as you have security systems in the car. So what is the security systems in the car? Like for example, we have an airbag in the car. Let's focus here. If this is the example, if you take, you have airbag. The purpose of airbag is to protect the driver or passenger uh, from any accident happens. If any accident happens, the driver should be safe. So this airbag balloon will open whenever some accident happens and saves the life of the driver. How does this happen? How does this airbag opens up? So it's a simple thing. The system is like this. You will have some sensor in front of the car. That sensor senses the signal, gives the signal. Whenever any accident happens, that senses that collision, hard collision, and that signal, that sensed signal will be given to the microprocessor. And microprocessor, when it gets input from the sensor, it will run some program, a small program inside that stored in the microprocessor, and it will activate, it will give the output, that is activate a motor driver or the airbag driver to make it open. This entire thing, that is getting the input from the sensor, going to the processor. Processor has to run the program, small program, and activate the airbag system. That is the motor to open up the airbag. This entire process has to be completed in a fraction of a second, because accident or collision happens in very short time. No time, simply to say, it's in fraction of seconds everything goes off. Right? So this system is very crucial and critical, life-saving system inside the car, which has to function, which has to complete its action in fraction of second. Let's say that time bounded. It is time bounded. The airbag has to open within a half second or less than that. So if your system, your processor or your program is not performing this task within that specified time bound, there will be a huge loss. There will be a human loss. The driver may die. Okay. So this kind of things are very critical systems, and these are called as real-time embedded systems. That is, they are working in the real time. In the real time, you are going in the car, suddenly accident happened, and the airbag has to act. So real-time embedded systems is one best example you can think of. You can simply say, as in definition, real-time embedded systems are time-bounded constraints. Okay, the programs what we write should work in the real time in a very short period of time, and we have to ensure the safety of the passenger, something like that. Okay, so that's the meaning of real-time embedded systems. Not only in the cars, we can think aeroplanes is another thing where we have a lot of electronics involved in the aeroplane, and security systems are involved. If something goes wrong when you're flying in the air, how to protect the passengers is a major concern, right? So aeroplanes, even if you think in hospitals, you have some system. This is named as ventilator, which is a life-saving device. When a person cannot breathe by himself or herself, this is a electromechanical system which will give the oxygen to the patient. So if this will this will inhale and exhale the oxygen from the patient by force mechanically. So this is again a critical life-saving system, and it should not fail at any cost. If something goes wrong in the system, the patient will die, because this is giving the artificial breath to the patient. So this is another example of real-time embedded system, critical applications. So that is why the name came as real-time embedded system. And what is standalone embedded system? Is you can think of your washing machine in your home, which is a standalone device. It will not move. What do you mean by standalone is? Non-movable things. This will not move anywhere. You will fix your washing machine at one place and you start running it. And this is not, even if you think of, even if power goes off in between, there is no such huge damage like the life of a human will happen. There is no such risk here. Just a normal embedded system. And what is network embedded systems are? So nowadays, all the devices are connected through internet. So there should be some kind of networking from one device to another device. For example, you are using your cell phone and connected to Bluetooth headphones, right? So your cell phone is one embedded system, your Bluetooth headset is another embedded system. So these two has to get connected, phone to your headphones. So you should have some kind of wireless communication or wired communication pin to happen between one device to another device, and they communicate with each other. And a lot of examples like that. So they are called as networked embedded systems, where two systems gets connected through internet or some other wireless technology or something. Okay. So that is one classification. And other things to see based on the performance of the microcontroller. What comes here is depends on the application, what type of application you are designing. You will have to choose a particular processor for that, a microprocessor. So depending on the application, there are various number of microprocessors available in the market. Depending on the application, we have to choose any one for our application. So if you think of the processors in the market, let's say we have various manufacturers of the microprocessors. Intel, AMD, ARM, NXP, that is Philips Semiconductors. All these are manufacturers of the microprocessor. So how do we select these things for the application? So it depends on, there are three factors we majorly consider. That is the power consumption, the clock speed, how faster your processor works, how less the power consumption it will take, and how much area it occupies on the PCB. These three factors plays a major role. For example, if you take the car airbag system example, the major factor there is the speed of operation, because your processor has to run the program very faster. The speed of operation, I have to choose the critical factor. Your processor has to be very fast. So I have to see. So in that application, I have to go for a processor which is having a good clock speed, like 2 gigahertz or 3 gigahertz of clock speed, where it can run the program very faster. Okay. That is the speed of operation of processor is one factor I consider. Suppose you are designing a mobile phone, which is a portable device which operates on battery. So you will charge your phone and carry your cell phone in your pocket. So the power consumption of the processor in that mobile phone application, power consumption of the processor should be very low, because it is operating on the battery. If the power consumption of the IC, the processor, is very high, the battery will drain out very faster. Okay. So in that application, I will have to choose a processor. The factor I consider there is the power consumption of the processor should be very low. So depending on the application, I will have to choose select a processor accordingly. That is what the classification is given. Okay. That is what type of, based on the performance of the microcontroller, sophisticated microcontrollers, or medium scale or small scale. And we have to see the economy also when we design something, like as you have more facilities, sophisticated processors will cost you much. So you should see the economical balance of your design and the market price of your design, all these things. Considering all these factors, you will have to select the microcontrollers. So that is how the things are classified. I hope you understood something from this. I'll stop here. Thank you very much for your patient listening.